Greetings, math fans. All right, so this is day 2 of solving linear equations. All right, so this is just kind of a special case. So day 2, again, this is solving linear equations. And remember what we did yesterday is basically you had to follow those different rules, right? You distributed, and then you combine like terms, and then you add and subtract and move terms on either side, you know, to get the x's on one side and get the numbers on the other side, and then your last step was you multiply or divide to solve for x. So here's the deal. Let me just kind of, this is kind of simple the way I want to show it to you, but if I get like 3x plus 7, let's say after you did some simplifying, you get 3x plus 7 equals 3x plus 7. You're going to do all your same work as you did before. You're like, oh, okay, I got to get the numbers on one side, so I'm going to subtract 7. And then I got to get the variables on one side, so I can subtract 3x from both sides. And so what happens is, if you notice, this cancels, right? Everything cancels. You actually get 0 on this side, and you get 0 on this side. So the special case that we're talking about, and this is really important, I'm going to put this in thick red. The variables cancel. This is it, man. If the variables cancel, so that means like this here, this canceled with this, right? You subtracted 3x to move it over, but they both cancel on both sides, so there's no more variables. When I say that, variables cancel, that means the variables are gone. That is a special case. Okay, so let's actually label this. This is kind of like I said, solving linear equations, but these are special cases. Very, very important, special cases. Okay, so again, this is it, man. The variable cancels. If the variable cancels, then what you do is you look at this final result right here. And is this true? Does 0 equal 0? Well, of course it's true. I'm going to write true. Okay, so if the variables cancel and the left side equals the right side, which it does, your answer to this problem is all real numbers. So you learned it 2 different ways, and I don't care what you do, so I'm going to teach you this both ways. All real numbers. You can say infinite solutions. And if you want, you could say, instead of say all real numbers, you can use this called double bar R. That stands for all real solutions. Okay, what this means is any solution works for this, no matter what. If I go back to the original problem of 3x plus 7 equals 3x plus 7, and I plug in 0, 18, 1.2 billion, negative 57,000, it doesn't matter what number I plug in, it will still work because the left side is equal to the right side. So it has an infinite number of solutions. Any number you give me, I can tell you that works for this problem. Okay? So that is, again, the variable must cancel, and then the left side equals the right side, so it's infinite solutions. Okay, so that's the first case. First case, again, is this guy right here. Is this. Okay, infinite solutions. All right, so let's do the next case. The next case is, again, I'm just going to show you with an example. So 3x plus 8 equals 3x plus 5. Okay, so you're going to move the 3x over, and then you subtract 8 to move that to the left or to the right side. Okay, and the x's cancel, and again the variable cancels. So I'm going to write that in big bold here. Variable cancels. Okay, very important. In order for this to be a special case, the variable has to cancel, and it does. But in this case, it's a little bit different because this does give you 0 on this side, right? You guys agree 8 minus 8 is 0, and then 5 minus 8 is negative 3. So this does not equal negative 3, right? 0 does not equal negative 3. So I'm going to say this is false. The other one was true. If this one's false, our answer for this is no solution. No solution. Okay? Because there's no number you can plug in that will make this work, because you'll always get something like 0 equals negative 3. Okay, so that you say there's no possible way to put a value of x in there to make this thing work. So this has no solution. All right, so two cases. Let me summarize this now. Okay, two cases. So it's really two special cases. Two special cases. The first one, again, I'm going to write it here I'll do it in blue now. The variables cancel. Okay, so after the variables cancel, you're either going to get 2 equals 2, 0 equals 0, 8 equals 8, negative 50 equals negative, that should be 0 equals, 8 equals 8, sorry, negative 50 equals negative 50, negative 1/7 equals negative 1/7. I don't care what it is. Negative a billion, negative 1 billion equals negative 1 billion. It doesn't matter. If they equal each other, we say it's all real numbers, or infinite solutions. That's an infinity sign, or double bar R. I don't care. Okay? The other case, of course, is 2 equals 5, 8 equals 7, negative 3 equals 1, 0 equals 5. Okay, negative 1/7 equals 1/7. But of course, these are all not equal. So I'm going to put a little not equal. And so you answer this one as no solution. Okay? So those are your two cases. But again, the variable, I cannot stress that enough. The variables need to cancel. If they don't cancel, you cannot answer it like this. If the variables don't cancel, it's like yesterday's notes. X equals 5, X equals 7, X equals 1.2 billion, whatever. Okay? I want to warn you a little bit. If you have problems like this, let's say it's 8x equals 0. Let's say the numbers look like they cancel. This is not no solution. So please don't write no solution because you still have a variable here. Okay? Your next step is going to be divide by 8. You got to follow through on everything, solve for x, and 0 divided by 8, if you type in your calculator, you get 0. So the answer is 0 for this one. Okay? That is an answer. The only time it's no solution or infinite solutions is when the variable cancels and you have 3 equals 3 or negative 7 equals 5. Okay, this is all real numbers. This is no solution. All right, so you're going to do all your work. Like, if for example, if I gave you, again, here, I'm sorry, I'm kind of going ahead of myself. If the variable cancels, then you have the cases. If the numbers cancel, you have 0. You know, 7x plus 3 equals 4x plus 3. You're going to subtract 4x from both sides and subtract 3 from both sides. That's going to give you 3x. This cancels. That cancels. So 3x equals, 0. This is not no solution. This is divided by 3. X equals 0. Because think about what this says, math fans. This 3x equals 0. It means 3 times what is 0? 0. So that's a solution. 0. Okay, if I did, let me give you a kind of a long one. 4 parentheses 2x minus 3 minus 7 equals 5x plus 3 times x plus 2. Okay, you're going to do everything the same thing. I'm going to distribute. So I get 8x minus 12 minus 7 equals 5x plus 3x plus 6. Right? Everything's the same so far. I'm going to combine like terms, those two. So 8x minus 19 is equal to 8x plus 6. Okay? I'm going to subtract 8x from both sides, and I'm going to add 19 to both sides. So the variable canceled. I know I've got a special case here, and this is 19 plus 6 is 25. It does not equal, this is no solution. Okay? But remember, if you get something like, 7x equals 0, please don't write no solution. If the variable's still there, divide it by 7, and you get x equals 0. Okay? So that's it, math fans. That is a special case to add on to what we learned yesterday, and you guys should be good to go and knowing how to handle if the variable cancels, either equals, which means infinite solutions or all real numbers, or doesn't equal, which means no solution. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.